In this video, we are going to be learning about derivatives. A derivative in calculus is the instantaneous rate of change in a function, which geometrically represents the slope of a tangent line to a curve at any specific point. Okay, so now that I said all of that, but what does that actually mean? Well, first, let's identify what the derivative formula or representation is. A derivative is represented by the limit of h approaching 0 and then f of x plus h minus f of x over h. Okay, and now what does this actually mean? First, remember how I said a derivative is used to calculate any point on any function, the slope of any point on any function. Well, let's say we want to calculate the value of a slope right here. But this is a curve. So how do we do that? Well, for that, let's plot down 2 points. So this is 1 point and this is 1 point. Okay. And now that point is represented by when we plug in x, it has to have an output. So that output is represented by f of x. Okay, and now what about the other point? So let's represent this point by f of x plus h. And the h is the distance from this point to the other point. Okay, so what does that mean for our output? Well, then that would mean our output is f of x plus h. I'm assuming you can start to see the resemblance in the points and the equation. But now, what does this have to do with the formula? Well, recall that the slope of a straight line is the points of y2 minus y1 over x2 minus x1. Okay, so what happens? Actually, first, let's draw a straight line through here. Right, we have a straight line through those points. I'm going to erase all of these because it's getting very messy. Okay, well, that's the point. That's the line going through both of the points, right? And now, the slope of these 2 points don't represent do not represent this point, the slope of this point. This line more so represents the slope of this section of the graph if you average that part out. So it kind of represents this, but if it's averaged. So how do we get it to that specific point? Well, recall that I used the slope formula. So let's try and plug in these values into the slope formula. Okay, so I'm going to be putting this over here. And I'm just going to be doing my math right in the graph. So y2 minus y1. So our y2 value is going to be it's a fraction, so f of x plus h minus, now this is going to be our y2, so it's this part. So f of x. Okay, and then it's x2 minus x1. So it's going to be first at this point, since this is x2, so it's x plus h, and then it's this point. So subtract minus x. So if we simplify this down, we get f of x plus h minus f of x over h. Now, that does look very, very similar to this. But what is this part of the derivative? Well, we need to understand what h is. H is the distance from these 2 points. So, if the limit is of at h approaching 0, it's just trying to say that if you made the distance ridiculously small to the point where you can't even see the actual distance, so no matter how much I zoom in, it's going to infinitely approach 0. So at a point where the distance becomes so small that it's negligible to us, we can just say that that is a tangent. So basically, if you made h ridiculously small, so basically you moved h all the way over here, right? So the distance of h is so small, it's right here, that it infinitely approaches 0. So what happens when it infinitely approaches 0? It turns from a secant to a tangent. So this is what the derivative formula is. So it will infinitely approach 0, but it will never reach 0. Hence, that's why we call it a limit. So the limit of as h approaches 0 is f of x plus h minus f of x over h. And that's how you derive the derivative formula. But now you may be thinking, well, how do we use derivatives in our daily life? Well, I'm going to be showing you just that. This is a graph of a car traveling 100 meters. You can see that there are 3 sections. So when you first look at this graph, you might think that it only tells us how far the car has traveled over time. The horizontal axis represents the time in seconds, and the vertical axis represents the distance in meters. But this graph contains much more information than just the position. Notice the shape of the curve. At the beginning, the graph gets steeper and steeper, meaning the car is accelerating. The car covers more distance every second because the speed is increasing. But now in the middle section, there is constant speed. The graph becomes almost a straight line. A straight line has a constant slope, which means the car is moving at a constant speed. Near the end, the graph begins to flatten out. The slope becomes smaller and smaller. This tells us the car is slowing down or deaccelerating until it finally stops at 100 meters. So, what does all of this have to do with derivatives? A derivative measures how quickly something is changing at a particular moment. On the graph, the derivative of the slope of the tangent line. So imagine zooming in on one point of the curve and drawing a line that touches the graph at that point. That point is called the tangent line. The steepness of that tangent line tells us the derivative. On this distance versus time graph, the derivative represents velocity or speed. When the graph is steep, the derivative is large, meaning the car is moving quickly. When the graph is less steep, the derivative is smaller, meaning the car is moving more slowly. When the graph is completely flat, the derivative is 0, meaning the car is not moving at all. This means we can determine the car's speed at any instant simply by looking at the slope of the graph. The visualization shows that a derivative is found by looking closer at the slope between the 2 points and then letting those points get closer and closer until they become 1 point. Just like how I showed here. I connected these 2 points together and to the point where h infinitely reached 0 and became so small that the slope basically became, the line basically just became a tangent to the point. Now let's connect this to our car. At the start of the trip, the derivative is increasing because the slope is getting steeper. That means the car is accelerating. In the middle of the trip, the derivative stays constant because the slope stays the same. This means the car's speed is constant. At the end of the trip, the derivative decreases because the slope becomes flatter. That means the car is slowing down. This leads to another important idea, acceleration. If the velocity is the derivative of the distance, then the acceleration is the derivative of velocity. This is why derivatives are so useful in physics, engineering, economics, and biology, and in many other fields. When we want to know how quickly something is changing, we use derivatives. In our graph, the derivative transforms a distance graph into a velocity graph. Instead of telling us where the car is, it tells us how fast the car is moving at every moment. And that should sort of give you an idea of what a derivative is and how it is used in physics. But now that we know that, let's do some math. Okay, I'm just gonna keep that. Let's move on to here. Okay, so for our first derivative, so hang on. Okay, so the first rule we're going to be learning in derivatives is going to be just so you know, the standard notation for a derivative is just d over dx. Right, so d over dx equals x to the power of n, and that equals n times x to the power of n minus 1. So that is called the power rule. Right? So, since that is the power rule, let's try and apply it to a question. What is the derivative of, let me write this down, the derivative of x squared? Hang on a minute and try and solve that by yourself. Okay, hopefully you've paused the video, and now you can see that the answer is 2x. Actually, let me show my work. So we have an x here, and the n is 2, so it's 2 minus 1, and it's multiplied by 2, so this just becomes 2x. And now let's apply this to a graph. I'm assuming all of you guys know what a parabola looks like, right? And this is going to be 1, this is going to be 2. 1, 2, 3, 4. just gotta put this on the other side. And the bottom side doesn't really matter. Okay, so now you might be asking, well, what does the 2x actually mean? Well, let's say I want to find the derivative at an x value here. So that has a value of 2, right? So this is 2. So 1, 1, 2, 3, 4. Now, what you have to do is plug in 2 to the equation. So 2 times 2 is equal to 4. So what that means, 4 is the slope at that point. Y equals 4x. So if you're looking, you see how that's basically the slope at that point? So that's how you use the power rule in the derivative. Okay. Now that we have an example problem done, let me write down some questions so you can practice by yourself. What is the derivative of d over d of x? I'm going to duplicate this a bunch of times. Duplicate, duplicate. Okay, what is the derivative of x cubed, x to the power 4, and x to the power of 5? Okay, so take a minute and pause the video and find those down. Okay, hopefully you've paused the video and find out the answers. So let's do them, right? So we have x and then the 3 to the x and then 3 minus 1 because it's n minus 1. So this is just going to be 3x squared. Okay, now let's do x to the power of 4. So this becomes 4 times x to the power of 4 minus 1. So this becomes 4x cubed. Now what does this equal? The derivative of x to the power of 5 is you bring the 5 to the front, so x to the power of 5 minus 1, and that equals 5 times x to the power of 4. And that's some basic derivatives. Okay, now let's get a bit more complex. Let's try d to the power d over dx of 5x to the power of 4. Okay, try and think what that might be. Okay, hopefully you've done it. So, what you do in this scenario is you do 5 times the derivative d over d of x power of 4. Okay, and as we remember, the derivative of x to the power of 4 is 4x cubed. So this is 4 times 4x cubed. So this ends up equaling 20x cubed. Okay, and now, so the answer to this question is it is 20x cubed. And that is our final answer. Okay, now I'm going to be giving another more sets of questions and see if you can do those by yourself. And then I'll give you the answer. Okay, take a minute to do those questions. Pause the video if you need to. Okay, so hopefully you've paused the video and you found the answer out. So, let's do this. So, 3 times the derivative of x squared, so that would be 2x, so times 2x. So that equals 4x. What is the derivative of 6x to the power of 7? This is going to be 6 times 7x to the power of 6. 6 times 7 equals 42, so 42x to the power of 6. And finally, what is the derivative of 3 times x cubed? The derivative is 3 times 3x squared, so it equals 9x squared. And that is if the derivative has a sort of coefficient. Now, let's do harder ones. Maybe you guys are ready for polynomial ones. I don't know. I think if we should go over polynomials or not. Yeah, let's just go over one polynomial question. Okay, so there's a constant rule and constant multiple rule. So the derivative of a constant times a function is a constant times the derivative of the function, where we went over that. But so the derivative of a polynomial is found by taking the derivative of each term separately using the power rule, the constant multiple rule, and the sum/difference rule. So yeah, let's do this. Let's do the derivative of let's do something simple. X squared minus x. So, we need to find the derivative of each thing. So first, let's find the derivative of x squared. That equals 2x, and the derivative of x equals 1. So, connecting this, our derivative would be 2x minus 1. Okay, let's do a harder question. 5x cubed minus 7x squared plus 3x. X minus 1. So pause the video and try and find what the answer to that is. So hopefully you found your answer out. And yeah, let's start doing the question. Okay, so d of x 5. Okay, we need to individually find each one. D of dx. Since there's 4 terms, I'm going to duplicate this 4 times. So this becomes 5x cubed negative 7x x squared plus 3x minus 1. So just so you guys know, the derivative of any constant is always just 0. The derivative of any like linear number or term, so like 3x, and it has a degree of 1, that automatically becomes a 3. So yeah, let's do these ones. First, this is 5 times 3x squared. So this becomes 15x squared. And what about negative 7x squared? So this becomes negative 7 times 2x. And that equals negative 14x. Okay, and now that we have all that information, let's assemble. So 15x squared minus 14x plus 3, and if you want, optionally plus 0, but we don't need that. And that is the derivative of a polynomial function. If you want to do, yeah, let's do one more. So what is the derivative of let's pick a bunch of random numbers. 5x to the power of 5 minus 4x to the power of 4 plus 3x to the power of 3 minus 2x to the power of 2 plus x minus 0. Yeah, hopefully you can see the pattern there. Okay, so yeah, pause the video and take some time to answer the question. Okay, hopefully you've done the question, and now let's get started. Okay, so we need to individually do each term. Okay. And now we need to put each term into, assemble it together as a derivative. 5x to the power of 5, negative 4x to the power of 4, three x to the power of 3, minus 2x squared, plus x, and minus 0. So, based on last time, this becomes a 0, this becomes a 1, and let's start. Okay, so let's start with negative 2x squared. So this is negative 2 times 2x, so that turns into negative 4x. This is 3 times 3x squared, and this equals 9x squared. This is negative 4 times 4x cubed, and this equals negative 16x cubed. And this is 5 times 5x to the power of 4 times 25x to the power of 4. And now let's assemble. Okay. So the derivative of 5x to the power of 5 minus 4x to the power of 4 plus 3x cubed minus 2x squared plus x minus 0 equals 25 times x to the power of 4 minus 16x cubed plus 9x squared minus 4x plus 1. And that is how you use the power rule for polynomials. Okay, and now there might be many nuances and different things. So yeah, let's get into those. So how do you do the derivative of x to the power of 1? Think about it for a moment and then pause the video and solve it. Okay, hopefully you've paused the video. So let's get started. For notation wise, since you're gonna need to show a lot of your steps, one thing you can do is f of x equals x to the power of negative 1. And now you can just write f prime, or it's not prime, just that tick mark, f of x. And then what that says is, hey, I'm taking the derivative of this function, and instead of writing d over d of x, each time I'm just going to write f and then that tick mark of x to indicate that you're doing a derivative. Okay, well, it's negative 1 times x to the power of negative 1 minus 1. And this equals negative 1 x to the power of negative 2. And this isn't really a clean format. So in the end, I'm just going to be writing f prime of x equals negative 1 x to the power of 2. Okay, and that is our first derivative question of any power of a negative number. So let's do 2 more practice problems to get the hang of it. D over d of x so that is, let's say, 5x to the power of negative 3, and then 1 more. Okay, take a minute and solve for those derivatives. Okay. So, while I recommend understanding how to do this, there is a formula for a derivative if it is, if the x term has a power that is negative. So I'm just be writing this down, but I recommend actually learning how to do the steps instead of just memorizing. And that is, so there are 2 parts to it. And this equals to negative n times x to the power of negative n minus 1. And in the end, it should simplify to negative n over x to the power of n plus 1. Okay, and now let's get started. So 5x to the power of negative 3. Alright, let's speedrun this. 5 times negative 3x to the power of negative 3 minus 1. Right? Just making sure. Okay. This is negative 15x to the power of negative 4, which ends up equaling negative 15 over x to the power of 4. Okay. And now, our next one. What is the derivative of 6 times x to the power of -7? So this is going to equal 6 times -7 x to the power of -7 minus 1, -42 times x to the power of -8. And this equals -42 over x to the power of 8. Yeah, and that's hopefully you learn how to do derivatives if it is to the power of an x. That is negative. Now let's try and do rational equations. There now. Let's make this small. Okay, so we're gonna be learning how to do the derivative of any rational function. So like 5 over x is x squared, or 6 over x to the power of 7, or 4 over x squared. So yeah, let's get started. What is the derivative of 1 over x squared? Well, that is going to be equaling. So the derivative of any rational function is actually basically the same of this. So because if you know your rational, like not rational, exponential rules, you know that anything that stays in the denominator, if you move it to the numerator, the exponent just becomes a negative. So we can use that rule to our advantage. This becomes x to the power of -2. And well, what happens is -2 times x to the power of -2 minus 1. So we end up getting -2 times x to the power of 3. Which equals -2 over x cubed. Okay, now that we have that, let's try and do some harder questions. What is the derivative of a over x to the power of 4? And 4 over x squared, 6 over 7x to the power of, I can't think of a number. What number should we do? My lucky number 7, so 7x to the power of 7. So yeah, pause the video and try and do these questions yourself. Okay, hopefully you've paused the video. And now let's do our first question. So d over d of x, so this turns to 8 times x to the power of negative 4. This equals 8 times negative 4x to the power of negative 4 minus 1. So that equals 8 times negative 4x to the power of 5. And this equals negative 32x to the power of negative 5. And that is our answer. On to the next question. 4 over x squared. So we're going to rewrite this as 4x to the power of negative 2. This equals, so we multiply by the exponent of negative 2 to get negative 8. Basically, we do 4 times negative 2, and then x to the power of negative 2 minus negative 1. And then all in all, we should get negative 8x to the power of negative 3. And this equals negative 8 over x cubed. Hopefully you got that question correct. And and this is, I don't know what happened here. This should be a 2. Oh, and if I had more space. Okay, we're gonna have to squish this in. I forgot to put this answer. This is gonna be x to the power of 5 and 32. Negative 32. Okay, and that is our answer. Time for the final one. Okay, 6 multiplied by 7x to the power of 7, negative 7. This turns into, geez, we're going to need a lot of space. So 6 times 7 is 42, x to the power of negative 7. And now we're actually going to do the derivative. So applying the power rule, we'd get 42 times negative 7 times x to the power of negative 7 minus 8. So this equals negative 294 times x to the power of negative 8. And this would equal and that is how you do derivatives of rational functions. Okay. Let's put that there. Okay, so now we are going to be learning how to find the derivatives of roots. So yeah. So what is the derivative of root x? Well, this is just going to be equaling x to the power of 1/2. So this equals 1/2 times x to the power of 1/2 minus 1. Oh, and hold up, I forgot it. I always remember that you should use notation correctly. Otherwise, you're probably going to get the points taken off on your test. So from now on, f of x, we're going to be solving like this. When you apply a derivative rule, only in that sense do you start using the notation. So now that I'm applying a derivative rule, I put the tick mark. So this is 1/2 by the power rule. This becomes 1/2 times x to the power of 1/2 minus 1. And this becomes 1/2 times x to the power of negative 1/2. And then this becomes 1 over 2 root x. Oh, well, there's one more extra step. And so this is the derivative. Okay, so hopefully you got that down. Let me write down some questions for you to do. Find the derivative of the cube root of x to the power of 5. Uh, 3, 5, 6, and 7, 4, and 1. Okay. So you can pause the video. Oh, this is a duplicate. Hang on. Just do 6 and 9. Okay, pause the video and find those derivatives. Okay. So, there's a formula for finding the derivative of a root, but I always recommend to actually learn how to do it. So yeah. Let me show you the formula first. D over d of x. So nth root of x. So that equals x to the power of 1 over n, which equals 1 over n times x to the power of 1 over n minus 1. So you can plug this your root value in and you should get this. And obviously don't always use the formula, try and show your work. Because in the AP exam, if you watch the interview with the person who goes over the actual AP tests, when you're doing like an integration or derivative of any function, you don't want to necessarily just put it into your calculator and get your answer. You want to show your work. The AP scorers want to see your work and how you got that derivative. Okay, so this formula, no, we're going to be doing the work by ourselves. Okay, so this becomes x to the power of 5 over 3 actually, so f of x, this turns to x to the power of 5 over 3. Now we actually apply the power rule. F prime of x equals 5 over 3 times x to the power of 5 over 3 minus 1. This becomes 5 times x to the power of... what happened? 2 over 3x minus 1 over... over 3. And depending on your teacher, you might be able to leave that answer down, but some might say to put that as a square root. So for your other teachers, here's the answer. Times the cube root of x squared over 3. And this is the answer. Let's use this one now. This simplifies to 3/12. I should have done that earlier. Not 3/12, 3 seconds or whatever. Oh, and I remember this has to be simplified. And depending on your teacher, that might be the answer, but 3 root x over 2. So, on to this question. So, f of x equals x to the power of 7 over 6. Yeah, and this is our answer. And for our final one, f of x equals x to the power of 1 over 4. So f prime rare scenario where the top actually becomes negative 3 over 4, so the bottom is 4, right? And we shift everything down. 4 times give me 1 sec. And this is our answer. And that is how you do derivatives of roots. So let's do some bonus ones. Actually, these aren't related, but let's just do one because I feel like it. X cubed dude, what is this circle? Cube plus 7. Take a moment and try and find that derivative. Okay. So, this is just f of and now 7x through 21x squared. Yeah, so this is the derivative. So when you get the hang of it, you can start doing these questions really, really fast. I feel like I want to do a miscellaneous one. Hey, live life with no regrets. Let's do another one. D over now that'd be a big number. So yeah, take a minute and try and do that question. Okay, hopefully you've done the question, so let's start. F of x so you can, if you divide, since you need to divide by all of them, you can simplify them in the end. So x to the power of 5 plus x to the power of 6 plus x to the power of 2. F prime, and then apply the power rules. 5x to the power of 4 plus 6x to the power of 5 plus 2x. So this is our answer. Okay, and that is how you do root derivatives as roots plus a miscellaneous. Okay, and maybe we could go over. Okay, here's what I'm thinking. We could do the trigonometric rules right now, or I could end the video. Yeah, let's just do the trigonometric values. Okay, so this is going to be a very, very long list. Okay. So let's get started. So the derivative of sine x is equal to cos of x. The derivative of cos of x is equal to negative sine of x. The derivative of secant x is secant x times tangent x. Oh, and for the derivative of cosecant x, that is going to equal negative cosecant x times cot x. The derivative of tangent x is secant squared x. The derivative of cot x is negative cs c squared times x. Okay, so I'm going to give you 2 minutes just to copy these down. So yeah. Pause the video, take as much time as you need, and you can skip forward 2 minutes if you don't need the time. Or maybe a minute, I don't know. Okay, so hopefully if you copy those down, and now there's going to be even more formulas to memorize. Yay. Okay, so along with that, you also want to memorize let's do okay. So first is I think it's called the product rule, but if you want to multiply two functions together, right? If you want to multiply two functions, so let's say d over d of x equals f times g. And f and g here just represent functions. So that's just f prime times g times f times g prime. Okay, and that's one formula. Okay, let's just focus on that formula first. So let's do a question regarding it. Okay, let's do d over d of x Okay, so x cubed times sine of x. So obviously these are two different types of functions. So this is going to become f equals x cubed g equals g. Okay, so you always want to write them out since there's going to be 4 terms we need to learn. So this is f prime is going to be equal to 3x squared. Time for g. So g is sine x. You already know that. And g prime is going to be cos of x. Okay, now that we apply the product, the power rules, everything, and our trigonometric identities, we can start applying this to f prime times g times f times g prime. So doing that, we'd get 3x squared times sine x plus x cubed times cos of x. And that is the derivative. Okay, let's try some more. So this is going to be a product rule without relating to, sorry, I'm blanking. Without relating to the trigonometric identities. So what is d over d of x So what is 2x squared plus 1 times x cubed minus 4? Now, I know you can FOIL this, but I want you to try and use the product rule, because the product rule is much, much more faster. Okay, pause the video and try and solve it. Okay, hopefully you've paused the video. And now let's identify what f prime, g, and g prime is. So f equals 2x squared plus 1. So that means f prime is going to be two x squared 4x. G is going to be x cubed minus 4, and g prime is going to be 3x squared. And now we multiply, so f prime times g times f times g prime. So and then simplifying, we'd get and this in the end equals 10x to the power of 4 plus 3x squared minus 16x. See how much easier that was rather than just foiling out? Okay. So those are our 2 example questions. Let's move on to something a bit harder. What happens when you have 3 functions multiplying together? So, d over tx times f times g times h. So, think for a moment and try and come up with what you think might be the 3-factor product rule. Okay. Hopefully you're done thinking. So what it's going to be is f prime. And if you don't know what I'm meaning by f prime, I already said this earlier in the video, but I'm going to be cutting these videos up into smaller pieces. But f prime basically is if you take the derivative of that. So whether using power rules or the trig identity formulas or the quotient rule or whatever. Okay, so f prime times g times h plus I'm sorry. So wait, this isn't a multiplication. This is an addition. Yeah, I didn't mean to make that mistake. So f times g prime times h plus f times g times h prime. So that is our formula, and let's do a question. What is d over d of x? So take a moment and try and figure out what the answer for that question is. Okay, hopefully you're done. And let's start listing out. You don't need to do this, but if it helps you, then I recommend doing it. So f is going to be equaling x squared and f prime, so the derivative of x squared is going to be 2x. So time for g. So g is equal to cos x. And g prime is equal to negative cos x. And h h is equal to x plus 5, and since this is a constant, h just becomes 1. And oh my god, this is going to be a very long multiplication. Luckily, there isn't any simplification, so that's good. Although, unless you want to simplify... No, you can actually. You can't. Oh wait, you can. Yeah. Yeah, you can take some stuff out of the parentheses. So I'm gonna be speed running this. Okay, let's go. So 2x cos x, x plus 5, x squared minus negative sine x, x plus 5, x squared cos x 1. And simplifying everything, we get 2x cos and this is our answer. Okay, and let's do one more question. What time is it? It's 1:54 a.m. right now. I still want to do some questions, so one more. But this is going to be very fast. So d over d of x, I might even just write down the answer, x cubed times tan x times 3x squared minus 9. Pause the video and solve. Okay, hopefully you've paused. And so let's identify. F equals x cubed. F prime equals 3x squared. G equals tangent x. And G prime equals 6x squared times x, and h equals 3x squared minus 9, and h prime equals 6x. And multiplying everything. Oh my god. Okay, come on. We only have like 20 more minutes, so. Okay, so 3x squared tan x And that is our answer. Very, very long answer if you ask me. Okay. That is going to be it for that section. And we have one more last formula. So what is the quotient rule? So d over d of x squared plus 4 over x minus 2. Wait, that's our question. Sorry. Formula. Okay. I'm thinking. I'm trying to reminisce the formula. I think. Oh, yeah, I remember now. So the formula is. Let me erase all of this. G times f prime minus f times g prime over g squared. Okay, so that is the formula for the quotient rule. Let's write down our d, f, g, f prime, and g prime. Oh, wait, no, g is... Okay, and now we just have to plug in everything. And this is the answer. Finally, finally, last question for the video. I want to make sure you guys get good practice, obviously. It's going to be a hard one too, so. Okay, take a minute, pause the video, and solve that question. Okay, now let's list out the f's and g's. F equals 3x plus 1. F prime equals 3. F g equals x squared plus 9. G prime equals 2x. And now let's plug into our equation, or our formula. Wait, did I skip a step? Oh yeah, I did. Sorry about that. And that is our answer. So yeah, as you can see, we did a lot of questions. We learned the power rule, how to do derivatives of rational functions, derivatives of roots, derivatives of trigonometric functions, derivatives of functions multiplying together. So yeah, overall we did a lot with the power rule, and we learned how to use a derivative and how you derive the derivative formula. So yeah, I hope you learned a lot and a little bit about myself. Right now it's 2:06 a.m. and right now I'm going to 9th grade, and in 9th grade I'm taking trigonometry and calculus. So yeah, the date is July 31st, so 10 more days till school. Thank you for watching, and goodbye.